In continuation to our earlier classes on digital human modeling and simulation for virtual ergonomic evaluation, today we are going to discuss our week 7th module, that is module 7. It is related to application of digital human modeling software in various occupational sectors. Mainly today we are going to discuss about application of DHM in agricultural sector. So, various application of DHM software in agricultural sector has been reported by various researchers. So, recently from a published paper by Patel et al. 2016, this paper is mainly review based paper. The title of the paper is Ergonomics Perspective in Agricultural Research, a user centered approach using CAD and digital human modeling technologies. So, in this paper authors mentioned actually they compared, they mentioned that compared to other industries, application of DHM technology has come late into agricultural setting. So, while we find that digital human modeling software is being used in other industry like aviation, aerospace, automobile industry from the very beginning of its inception, but in agricultural sector its application has been started late. Most of the available literature reported application of DHM in off-road vehicles, specifically tractor cab. Whatever application of DHM software we can find in the field of agriculture sector, these are mainly related to off-road vehicle and specifically tractor cab. Several researchers have applied computer-aided simulation techniques for conducting human factor engineering analysis like controllability, comfort, lumbar force on a new model of versatile agricultural power carrier. Papers related to application of DHM in agricultural sector discuss about human tractor oblique power carrier interface design, as for example well accommodated operators enclosure, that is cabs and protection frames, controllability of driving, field of vision, diverse degree of comfort in driving, location of various controls, applications and features of DHM, etc. So, in most of these papers related to digital human modeling software's application in agriculture sector deals with all these areas. So, this image has been taken from the same paper Patel et al. 2016, and in this paper, in this image, authors mentioned or tried to show through the images that how digital human modeling softwares are being used by various researchers in their research. So, we can see it has been used for tractor cab design, farm tractor, then mill agricultural power carrier, fish processing factory, for designing fishing vessel. So, in most of the cases, so all the references are provided in this image, and which platform those researchers have used, that is also mentioned, and which ergonomic issues they have considered in their analysis, that is also mentioned here. So, from this image it is very clear that various researchers have already used digital human modeling software in the field of agriculture and also in the field of fish processing industry. So, now we are discussing the schematic diagram where the structure and function of ergonomic evaluation system of 3D tractor cab has been explained. So, this is also adapted from Patel et al. 2016. So, in this schematic diagram, authors mentioned that how 3D tractor cab can be evaluated using digital human modeling software in virtual environment. So, first it is started from requirement of database. Which database we require? We require the database for farmers or tractor operators. So, there are anthropometric data, that is static and dynamic anthropometry, that is required. Then we require biomechanical data related to range of motion, force, torque, etc. Similarly, comfort range, single joint or multiple joint comfort data is also required. So, these are the database required for developing the or creating the digital human model of the tractor operator or farmer model. So, based on all these data, anthropometric, biomechanical, comfort data, we can create digital human model for tractor operator or farmer. When this model is ready, then we go for creating 3D virtual environment. How we create this 3D virtual? So in one hand, our digital human model or digital mannequin is ready. On the other hand, we have to create the digital cab model of the tractor. For that purpose, first we are starting from this side. So cab information is required. Which are those information? Need identification, design limit selection, design dimension, material selection, cost, 2D sketches and concept development. So all this information is required. While this information is with us, then we can go for digital cab model developing. Design variables, for example, driver seat, steering wheel, various controls, hand controls, display, dashboard. So all these components are designed, then assembled, and ultimately we create the three-dimensional CAD model of the tractor cabin. While digital human model is ready or mannequin is ready, at the same time CAD model of the tractor is ready, then both these things are bring to the virtual environment with proper interfacing. While digital human model is interfaced with the tractor cab model, then we go for various ergonomic evaluation. So these ergonomic evaluations include vision analysis, that is interior exterior visual field from driver seat. Then we can go for reach analysis, steering reach analysis for various controls like steering wheel, foot controls, hand controls. Then we go for postural analysis with various posture evaluation tools like ruler, REBA, WAS. Then we can analyze comfort, discomfort, we can analyze clearance interference, we can study ingress egress, and various other ergonomic issues can be evaluated while this interface is ready, mean the tractor cab model interfaced with digital human model. Then following all this evaluation, if we find that everything is okay as per our requirement and there is no problem, all the digital human model derived from the targeted user population, they can operate all these functions comfortably, efficiently, then we can go for final design, finalization of the design concept, and we can go for prototype making and at the same time documentation. But if we find that there is some loopholes, some design modification is required, following all these analysis, if we find that design modification is required, then we have to go for design modification. Again, following the design modification, we will make the changes in the three-dimensional tractor cab model, and again we will go for the same loop for evaluation. And after that evaluation, if we find that everything is fine, everything is acceptable as from the point of view of human factors, then we can go for final prototype development. So through this schematic diagram, authors mentioned that how digital human modeling software can be used for analyzing the tractor cab from considering various ergonomic aspects. Now we are going to discuss few research papers in the field of agriculture where digital human modeling software have been effectively used. So first paper is entitled Immersive Ergonomic Analysis of Console Elements in a Tractor Cabin. So authors Dezinger et al. 2000, they developed a virtual ergonomics evaluation tool, Argonaut, based on virtual Anthropos. This is the earliest software. Based on this software, they developed Argonaut for evaluation of ergonomic features such as comfort, discomfort, reach envelopes, visual fields, and force isodynes. They demonstrated analysis of a model of the tractor driver's cabin on 3 different basic levels. So first level is quantitative discomfort values for 81 joints of the virtual human model. Next, quantifiable ranking values based on ergonomic assessment. Third level is the subjective testing by users on the basis of a mixed mock-up, hybrid mock-up with real seat and real control and virtual cabin. So in this particular research, they not only conducted the research in virtual environment, with digital human modeling software. At the same time, with real subject, they collected the feedback using the hybrid mockup, where real seat, real controls are used in the virtual workplace environment. All aforesaid levels are developed for use in immersive virtual reality system, that is CAVE. So here from this image it is seen that this is the discomfort values of virtual anthropos that can be evaluated, then various ergonomic analysis, ergonomic classes, subjective testing, and last one is the real setup for with seat and steering wheels, where real human can sit and he can interact with the CAD generated virtual environment, but these components are real. So this actually used for subjective evaluation, where real subject can sit and they can give their feedback based on the input received from the virtual environment. Xiao et al. 2005 in their paper Anthropometric Criteria for Design of Tractor Cabs and Protection Frames. In this paper, researcher investigated farm workers' anthropometry and determined the critical anthropometric measures and three-dimensional feature envelopes of body landmarks for designing the tractor operator enclosures. After anthropometric data collection using 3D body scanner, 15 representative body models are derived from the principal component analysis for tractor accommodation test. So these are the 15 representative body models derived from principal component analysis for tractor accommodation test. And in this image, we can see the surface envelope of 15 human models. So 15 human models are positioned on the seat, and the surface envelope, that how much area is required for accommodating these various different types of human models. There is variation, anthropometric variation for 15 models, how much space is required and how much is the variation. So this is the surface envelope for 15 human models. So this is from side view and this is from top view. Their study output included first, identification of critical anthropometric measurements for accommodation analysis. This accommodation analysis included overall accommodation, steering wheel impediment, gear handle impediment, positioning of protection frames in tractor design. Anthropometric models of tractor operator and three-dimensional feature envelopes are also derived. Tractor designers can import data of the 15 body models, as we have seen in the earlier image. So these 15 models, it's anthropometric data. So these 15 body models, any designer, any engineer can import those human models in their respective digital human modeling software for evaluation tractor design or tractor cab design using relaxed driving posture, as well as for many other postures which designer can simulate with the help of digital human modeling software. So actually from this study we are getting these 15 digital human models, and those models can be used for further study. So if we look at this image, on left side it is shown landmark location, 8 selected body elements. These are the 8 selected body elements. For 8 selected body elements, these are the landmarks of the 15 representative body models related to an average model. So this is the average model. Around that average model, for each of the body landmarks, how will be the distribution of the landmark dispersion for 15 numbers of human models. That is shown here. On the other hand, on right side, this image B, it is showing the 95% ellipsoid representation of the feature envelopes for the 8 selected landmarks to the tractor workspace from side view of the workspace. So from side view, for each of the landmark, so this is the left toe. For 15 human models, how should be the position of the left toe? So that is the ellipsoid for that. Similarly, say for vertex, so this is the area for to cover 95%. This is a 95% ellipsoid. It means 95% of the population vertex will be covered within this area. Next, Landström et al. 2008, in their paper Visualization of Comfort and Reach in Cab Environment, they proposed a general working method for deriving optimized reach and comfort envelopes for the evaluation of tractor cab layout design. So, this paper is also related to tractor cab layout design, and they proposed a working methodology. The working process considered the following steps. The first step was identification and generation of representative mannequins. A predefined percentile composition of 12 mannequins ensuring accommodation of 95% users available from Ramsys software was used to define the targeted group. So, as the targeted group or target user population, they selected 12 mannequins from Ramsys topology. In Ramsys software, these 12 mannequins are all predefined, and these 12 mannequins are actually developed from percentile composition of predefined percentile composition, and it can cover 95% of the users. If the facility is evaluated with these 12 human models, then we can assume that the facility can be used by 95% of the user, because these 12 mannequins actually comprised of different percentile body dimension, which is representative of 95% of the population. Then posture prediction was done using Ramsys software. Next step, translation of posture and anthropometric data from Ramsys software to JAX software. So, from this first posture was given, posture prediction was made, and that posture and anthropometric data was transferred from Ramsys software to JAX software. So, here from this image we can see driving forward, twin track and looking backward. So, this is simulated with Ramsys software. After that, alias joint surface spheres of Ramsys mannequin and positioning object. So, from this model, these body landmarks are extracted, and based on those body landmarks, JAX human models are given a particular posture. Then various ergonomic evaluation was performed, which include generation of comfort envelopes, generation of reach envelopes. So, here it is shown that comfort envelope for human model. So, this is the comfort zone for hand operation. Similarly, this is the reach envelope using Ramsys software. And next, they went for assembly of visual guidelines. So, from this image we can see 3 color codings are there. Red for the limiting reach surface. So, red one is for limiting reach surface. Then yellow one is the all comfort spheres. So, for 12 mannequins, the combined comfort sphere is this yellow portion, and the green portion is actually the common envelopes or union of comfort envelopes, that is represented in green color. So, this is the union of comfort envelopes for 12 representative mannequins. This one is the combination of all comfort spheres for 12 mannequins, and the last one is the limiting reach envelope or reach surface. So, in this way, following this methodology, that they developed the methodology where they showed that this type of using a group of mannequin, they can transfer the posture from one software to another software, and ultimately they can go for various types of ergonomic evaluation for tractor cab design. In the next paper by Jiao Yan et al. 2009, the title of the paper is Expert System for Tractor Cab Man-Machine Interface Evaluation. In this paper, researchers developed an expert system using Visual C++ and Clips, and this system can be used to evaluate man-machine interface of tractor cab quickly and find the shortcomings in the design. and if it can be identified, then accordingly design modification is possible. Effectiveness of this expert system was demonstrated through evaluation of a tractor cab model. In the reported research, Jiao Yan et al. 2009 presented the structure and function of the system. They also put forward the knowledge expression, reason mechanism, and the design and build method of knowledge base. Now, if you look at the image, it is showing the digital human model seated on the tractor cabin seat and operating the controls. So, this expert system was ultimately, they demonstrated that this expert system can be used for tractor cab design and design modification. Fathala et al. 2009 in the research paper entitled Ability to Youth Operators to Reach Farm Tractor Controls, the researcher investigated the abilities of youth operators with varying age and anthropometric characteristics to reach farm tractors controls on 25 tractors which are common in use in USA using SamiCAD software. So, in this particular research paper, they investigated that whether the youth operator, actually the tractor and tractor cabins, all these are designed for adult population, but whether those tractor can be suitable for youth operator, they studied using SamiCAD software. It was observed that many tractor controls, especially those that are hand operated, may not be effectively reached by the majority of the youth operators within the age group of 12 to 16 years. Their study findings supported the establishment and refinement of policies and guidelines related to the youth tractor operation. Researchers stated that the approach of ergonomic evaluation using CAD software as demonstrated in present research would be applied in similar situation where youth operators are involved. So, now these are few steps how that analysis has been done. So, from the original tractor using marker, they derived this type of model or data points for developing the CAD model of the tractor. So, for this purpose they use photomodeler software. So, photomodeler, in this image it is showing photomodeler showing steps towards resulting spatial representation of the tractor. So, from the marker pasted on the tractor, so they took images or took photograph from different angles, and based on those images with the software photomodeler, they derived this type of CAD model. So, properly scaled 3-dimensional virtual tractor mockup was developed using photomodeler software. Then that model was evaluated using SamiCAD software. With the SamiCAD software, virtual 3D human was developed, and that was interfaced with this CAD model of the tractor, and various types of ergonomic evaluation was performed. So, in next research paper, title of this research paper is Design of Agricultural Equipment Cab based on Virtual Reality. So, this was reported by Ying et al. 2010. So, here the researchers have used OpenGL 3D graphics software for designing the tractor and combine harvester 3D cabs. The cabs are evaluated by 50th percentile mannequin. Although it was possible to evaluate with 50th or 90th percentile for representing various body dimension of user population, it would have been possible, but particularly in this research paper they used only, authors have used only 50th percentile mannequin in virtual environment using combination of OpenGL and virtual reality software Multigel Vega Prime. They describe the development of virtual design system for agricultural equipment cab with the following steps. So, this virtual design system, what they proposed, it actually they follow these steps. So, first step, developing parameterized model of the agricultural equipment cab with all its components. Those components are enclosure, hand controllers, foot controllers, display component and driver seat. So this was developed with OpenGL software. Designing data regarding human-machine interface in agricultural equipment cab are managed by linked list and transferred from host computer to virtual reality system for vivid display and subjective evaluation by socket mechanism or socket method. In the virtual reality system, parameterized model are displayed by involving the mixture of virtual reality software, that is Multigen Vega Prime, and modeling language OpenGL. Next, a virtual design system was established based on ergonomics theory, design criteria and virtual reality technology for evaluation of the agricultural equipment cab. Finally, a tractor cab and a combine harvester cab were designed and evaluated with this system for demonstration of the effectiveness of the proposed system, that is virtual design system. So with this example of tractor cab and combine harvester, they demonstrated how their software is effective and how it can be used. So here are the steps that how that system works. So start, determine the construction of the cab, choose the mannequin according to the percentile age, sex, then design the driver seat, design the controllers, design the foot controllers, hand controllers, design panels, design meters and indicators light, objective evaluation. So we need to follow all these steps and these to be displayed in virtual reality environment for subjective evaluation. So one side we can evaluate using this type of digital human modeling software, where we can put digital human model and we can go for various types of evaluation using 5th percentile mannequin. On the other hand, for getting the subjective rating, subjective perception, the same these CAD models of the components and the overall tractor cab was presented in virtual reality environment to the real subject for subjective evaluation. If it was found satisfactory from both the aspects, from virtual analysis as well as virtual simulation analysis as well as from subjective evaluation in virtual reality system, if in both the situation it is found satisfied, then we can go for change a mannequin. So if it is analyzed with 50th percentile, then we can go for analyze with another mannequin, and if it is found that no obtain the final design proposal, if it is found that there are no changes is required, then we can go for final design proposal and there will be the end of the process. And if we find that there is some, if it is not at this step, if we find it is not satisfied, then we go for adjustment of the components and again we will come to this step. If it is found satisfied, then we will go towards the end and we will go for change even with after evaluation with a particular mannequin or a particular human subject. If we find it is satisfied, then again we can analyze it with different mannequins and again we can follow these steps. So in this way, following the schematic diagram, they represented how their virtual system works. So using this system, they ultimately, as you mentioned in the earlier slide also, so they design a combine harvester and also tractor cab. The next paper is limitation in fields of vision for simulated young farm tractor operators. This was reported by Chiang et al. 2010. The researcher tried to quantify how the field of vision of children or youth tractor operators who have varying anthropometry or whose anthropometry is different from the adult population. And so researchers tried to quantify how the field of vision is defined for the children or youth operators. Following their study on 42 popularly used tractors in USA, they concluded that youth operators typically had diminished field of vision compared to the average adult operator. This reduced field of view might have serious consequences in terms of risk for runovers, rollovers or collision, because those farm tractors are actually designed for adult population. But in USA, particularly it was seen that youth or children are operating those farm tractors. So while they are operating, what type of problem they face in terms of visual view field or visual obscuration, that was addressed in this particular research paper. So in this study, digital mannequin of tractor operators were created for youth tractor operators whose age ranges between 12 to 16 years, and 5th, 50th and 95th percentile models are created using SamiCAD software for the children model. Similarly, with the SamiCAD software, 50th percentile average size adult human model of same gender, either male or female, was also created for comparison. Children anthropometric data from the database of Snyder et al. 1977 are used for developing that children mannequin of 50th and 90th percentile. Three-dimensional digital mock-up of the 42 tractors are generated using photogrammetric techniques using photomodeler software. So in this image we can see 5th percentile 12 years old boy operating a tractor. This is the left side image, and the right side image while he is looking forward or straight ahead, how much is the visibility in the view field, what object they can see. Field of vision evaluation was performed after interfacing the three-dimensional digital mock-ups of the tractor with the appropriate 3D human models or mannequins, that is either children model or adult model. Study result indicated that the degree of visual limitation is greatest for objects at close distance and when the objects are straight in front of the operator. So visual limitation is more while those objects are closer or it is straightforward. Study findings was oriented towards development of policies and guidelines in tractor related job for children in North American farms. So if we look at these two images, upper and lower images, so the upper one is this image depicts an example of how much a 5th percentile 12 years old boy tractor operator could see out of 2 meter vertical bars. So 2 meter vertical bars are positioned in front of the tractors, and from the driver's seat a 12 years boy how much area or how much portion of these bars is visible or is visible to that operator, it was studied. So you can see 2 meter vertical, so these bars are of 2 meter verticals, and these were positioned at 0 degree, mean just in front, and then 30 degree, 60 degree and 90 degree in right side. Similarly, while those vertical bars are positioned at 3 meter distance, then how is the visibility? That is depicted in the bottom image. So in this particular study, researcher clearly showed that as the tractor was originally designed for adult population, while those tractors are being operated by children or youth population, then their visibility is actually reduced, and due to this less visibility, there is the chance of accident. And this information is very important in developing the policies. Yu et al. 2012 in their research paper, computer-aided human factor engineering analysis for a versatile agricultural power carrier, the researchers studied the human factor related problems of power carrier through computer-aided simulation analysis technique. So in this research paper, researchers used digital human modeling. So in this research paper, researchers studied the human factors related problems of the power carrier through computer-aided simulation analysis technique. CAD software packages, SolidWorks and ideas are used to develop the computer model of the CAD model of the power carrier. So two softwares they have used, SolidWorks as well as IDS, for developing the CAD model of the power carrier. Human model of 5th, 50th and 95th percentile male and female are developed from the Taiwanese labor anthropometric database using JAX software. So using JAX software, they developed defined percentile human models for both male and female from the Taiwanese labor anthropometric database. They addressed the issues like controllability of driving, driver's degree of discomfort in driving, and the lumbar force condition of the operator while lifting cargo from the cargo bench of the carrier. So these various ergonomics aspect or human factor issues, for this type of various tasks, they analyze the human factors issues. They observed that the existing design of the power carrier was satisfactory in terms of driving controllability for all percentile mannequins, starting from 5th to 95th percentile under study, but only 5% female drivers can operate the carrier comfortability. So in terms of comfort, it is not actually acceptable for wide range of the targeted population, but from driving controllability, it is acceptable for the entire range of the population. The present design were found to be too confined for most operators, especially for large mannequins. They found that the setting of the driver's seat and the driving handles backward by 10 cm could improve the accommodation problems to allow all but 90% male workers to operate the carrier comfortably. Lifting cargo weight under 25 kg did not exceed the limit of 3400 Newton, that is the safety limit for lumbar compression, L4, L5 lumbar compression. So from this study, it was observed that while the operators are handling only 25 kg load, then there is no risk. But if again they proposed that this lifting cargo height can be increased little bit, then there is less force, force can be reduced. The spinal compression force at L4 L5 level can be reduced by design modification of the lifting cargo. So these are one example of optimal reach analysis by advanced reach analysis tool. So this is from front view, this is from top view, this is from side view. So and here it is shown that how cargo lifting is being done. So in the next paper is a top-down approach for virtual redesign of the ergonomic optimization of an agricultural tractor's driver cab. This was reported by Geronimo et al. 2012. So in their paper or in the research, Geronimo et al. 2012, they used advanced technologies like CAD, DHM for illustrating the redesign and ergonomic optimization of agricultural tractor's cab. 3D CAD model of the tractor based on manually measured dimensional data of various components of real tractor was developed by assembling individual components with the main skeleton following top-down approach using CATIA V5 software. So here it is shown that how this top-down structure works. So this is the basic tractor cab model. In the tractor cab model, individual components or sub-components are installed to get the actual environment of the tractor cabin. So they also defined a new index called Ergonomics Evaluation Index (EEI), taking into account the postural angles of the operators and rapid upper limb assessment analysis tool available in the ergonomics design analysis module of CATIA V5 software. So based on the ruler analysis, rapid upper limb analysis and postural angle, they developed this ergonomics evaluation index. The index was validated by comparing the result of tests carried out using digital mannequin as well as the same task by real operators. Researchers suggested to modification of the shape and the position of the same control devices in order to optimize the ergonomics of the driver cab based on the critical values of ergonomics evaluation index obtained during some driving task in virtual environment. So here it is, we can see virtual prototype of the tractor, then how reach evaluation is being performed, then comfort range for particular body joint, then position of various types of controls, and based on the position whether the operator can visualize that control that is coming in separate window. So this is before repositioning. So in the existing scenario only this much is the visibility, but while it was after repositioning, while it was repositioned, then it was easier to visualize the control by the operator. So in this various ergonomics aspects of control location or control position was studied in that research. So next paper is concept design in virtual reality of a forestry trailer using QFD trees based approach. So this research was reported by Melemej et al. 2013. Researchers designed the timber trailer which can be attached with the agricultural tractor for manual loading operation suitable for rough terrain condition. The product concepts are designed in parametric CAD software and simulated using ergonomic digital mock-up tools. Quality characteristics of product development, customers' requirement and customer satisfaction are assessed by house of quality diagram. Several concepts are evaluated in an immersive virtual reality environment. An optimal model was identified based on the analytic hierarchy process. So in this particular process, using virtual reality environment as well as various others quality characteristics of product development analysis like analytic hierarchy process, they identified the optimal solution. So it is this image is showing house of quality diagram. Then concept generated in virtual reality system. And in this particular paper, lower back analysis was performed for the loading operation. So while these timbers are being loaded in the carrier, then their low back analysis was their low back compression force are analyzed. Dule 2012 in his research paper Ergonomics and Development of Agricultural Vehicles, researcher mentioned about the physical and cognitive aspects of ergonomics in modern product development including agricultural vehicle. So that has been actually discussed in this research paper. After positioning the digital mannequin of the operator on the seat model, pedals, steering wheel position are prescribed in relation to the seat index point. So after positioning digital human model on the seat and based on the posture, researcher defined where should be the position of the pedals and steering wheel in relation to the seat index point. Once the virtual product is ready, digitally we can validate the ergonomics as mentioned by the researcher. Aspects such as occupant packaging, reachability and vision can be evaluated the physical interaction of human with product. So here it is shown example of seat, the seat index point of the seat and the ideal placement zones for steering wheels, center and pedals at rest. So this is the pedal position and this is the steering wheel position in relation to the seat index point. And while at the same time, while digital human model is positioned, human inserted to the seat index point and showing various ISO 4253 zones, zones for various controls and its optimal location. Young et al. 2013 in their research paper Ergonomics Evaluation Method of Tractor Cab based on ProE mannequin. In this research paper, researchers demonstrated the successful use of virtual ergonomic evaluation using digital mock-up and mannequin to accommodate wide range of targeted population with varying anthropometry, that is from 5th percentile to 95th percentile body dimension. They redefined position of the hip point of a tractor cab and evaluated sitting comfort, visual performance and operational activities by inserting Chinese male model developed by ProE mannequin in the CAD model. Ranges for optimal position of various controls from acceleration heel point for easy operation are identified along with the provision of maximizing visual performance. So these are various images taken from that particular research paper where it is shown manipulating steer, that how that digital human model has been positioned in that tractor cabin and various types of operation is being performed. Using steering wheel, manipulating the lift control lever, operating front console, vision for the horizontal plane, manipulating gear lever. So various activities performed by the tractor operator can be evaluated using this ProE mannequin, and that has been demonstrated in this particular research paper. The next paper is reported by T.A. Cheng 2014. Title of the research paper is The Study on the Ergonomics of Hand Tractor based on Digital Human Model. So in this research paper, researchers successfully demonstrated the use of 5th percentile digital model of Chinese male for ergonomic design evaluation of hand tractor, and they used Creo software. CAD model of the hand tractor was used to evaluate seat design, pedal operation, control placement, vision and reach envelope to ensure safety and comfort of the operators. So as it is mentioned, so using the Creo software, so this Creo software was used for both developing the CAD model of the hand tractor as well as for developing the human model. So there is also human module of the Creo software. Based on that human module, they developed these human models or mannequins, and the evaluation they performed only for the 50th percentile digital model, and various aspects they studied, that is they evaluated reach, they evaluated so T.A. Cheng evaluated reach, vision. Then in this image we can see how much is the, while that operator is looking in front, that how much portion of is actually coming in his view field. So these are the objects coming inside the view field. Similarly, discomfortable posture in seating operation. So these aspects are studied by him. Now we are discussing the next paper by Montel et al. 2010, and the title of the paper is Modeling and Simulation of a Fish Processing Factory Ship. This paper represents a case study in a fish processing factory ship with onboard facilities for immediately processing and freezing of caught fish. So this is the overall layout of the workplace where various tasks are being performed in various groups. So this is that fish processing factory, and this is also on the fishing vessel. So an exploratory simulation model of the plant and human task was developed by the researchers. The analysis approach used discrete event simulation as well as digital human modeling techniques. So they use discrete event simulation for studying various aspects related to time study, related to individual workstation evaluation, but for this is more general purpose, but for particular workstation, for considering various ergonomics aspects, they used digital human modeling technique. Ergonomic evaluation of the wrapping activity consisting of several components of subtasks like pickup, trimming, place on the tray, plastic sheet between layers, tray placed on freezer belt are modeled in Delmia V5 software. And the 50th percentile mannequin of the French fishermen are developed using this Delmia V5 software. And that model was used for ergonomic evaluation of wrapping activity. So various ergonomic aspects like the Ruler score indexed, L4, L5 spinal compression force analysis for biomechanical risk analysis are performed by the researchers. Ergonomic and operational analysis of the wrapping operation studied in the present research help in improving both working condition and productivity. So, if these four images actually depicting the real working scenario in the wrapping process. So, real posture during the wrapping operation. So, first they are picking up the plastic, then cutting that or trimming, then wrapping, and then ultimately place the tray. The same activities are simulated using Delmia software, and here it is shown that the same activities like pick up, cutting, placing, and ultimately place the tray. So, place the fillet and ultimately place the tray in the conveyor belt. So, that is shown here. So, this evaluation was very important because it helped in improving both working condition in that factory on the fishing vessel and also to improve its productivity. So, in earlier paper we discussed about the application of digital human modeling software in agricultural sector. Particularly we can find that most of these applications are related to tractor cab design or agricultural power carrier design. Not only this agricultural sector, so we can from this research paper we can see digital human modeling is also being used for fish processing industry also. The next paper is also related to fish processing fishing vessels. So, title of this paper is Using Anthropometric DHM Prevention of Occupational Hazards on Board Fishing Vessels. This was reported by Zhang et al. 2010. This research was carried out towards improving occupational health and safety of Spanish fishermen and for redesigning the workplace of onboard small fishing vessel. The work postures of all the fishermen are simulated and assessed by using ergonomic digital human modeling system. So, they used Mannequin Pro software. So, first they studied the activities which are performed in that small fishing vessel for fish processing. Those are studied, problems are identified, and those are simulated in digital human modeling software using Mannequin Pro. This Mannequin Pro software. So, in that research paper, in the tabular form, they represented that how design modification is first evaluation with the digital human modeling software and how modification of the workstation can be done to obtain better posture of the fishermen or persons who are involved there in various activities. So, in the first column they explain various tasks. So, here only 2 tasks are shown, but there are actually 3 basic tasks. So, tasks are shown on first column, then digital human modeling with bad posture in the existing scenario, what type of posture they are adopting, why in those posture, various risks are associated, that is mentioned in the third column. Then what type of solution can be provided, that is given here, and parameters of the digital human model in acceptable postures, how posture can be improved, and this is the finally it is shown that how posture is improved after that design modification. So in this way, researchers have demonstrated very nicely that how digital human modeling software can be used for improving the working condition in those small fishing vessels. So these are the list of references which have been used in various slides. So we can go through these research papers for getting more information related to this particular topic, application of digital human modeling software in agricultural sector. These are remaining references. So I suggest all the students, as I have also suggested you in earlier modules, that these are only few research papers which I have collected. So you can go through more research papers in that particular domain to get more idea about application of digital human modeling software in that particular occupational sector. So thank you.